Hi guys, welcome back to Maths with Cats. So in today's video we're going to go over the quadratic formula, how to use it, and why it's useful. So let's go to our first cat of the day, very cute. So we're going to use examples to teach this because it's the easiest way to teach it. So solve the quadratic equation 3x squared minus 4x equals 8, leaving your answer in third form. Well, first of all, we'll rearrange it to get it equal to 0. So 3x squared minus 4x minus 8 equals 0. And from this, our a, b, and c, which we need in the quadratic formula, are 3 minus 4 and minus 8. Quadratic formula here, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we sub our a, b, and c into that, so we end up with 4 plus or minus the square root of minus 4 squared minus 4 times 3 times minus 8 over 2 times 3. We're then going to simplify that, and we'll get x equals 2 plus 2 root 7 over 3, or 2 minus 2 root 7 over 3. And, being a cat, you know you've completed that. Oh, I like that rhyme, I might use that. Okay, so an important part of the quadratic formula is the discriminant. Discriminant is the part of the quadratic formula I've highlighted here, so b squared minus 4ac. If b squared minus 4ac is more than 0, the equation has two distinct real roots. So this is what a graph looks like if it's got two distinct real roots. It crosses the x-axis twice in different places. If b squared minus 4ac equals 0, the equation has one repeated root, so that's this one. So you can see it kind of bounces off the x-axis. That's the way I think of it. And if b squared minus 4ac is less than 0, the equation has imaginary roots or no real roots. So this is what that looks like. So it basically just means it does not touch the x-axis. It does not cross it at all. These you can also have these for n-shaped graphs. Here we've used all U-shaped graphs. It'd just be the same, but here it would go and up to just over this. Here it would go up to touch the axis and bounce back down rather than bounce back up. And here it would just be completely under the axis rather than completely over the axis. Here is another cute cat. So here's some more examples. So first one, by finding the discriminant, find how many real roots 15 minus x minus 2x squared has. So here a is minus 2, b equals minus 1, and c is equal to 15. b squared minus 4ac is therefore minus 1 squared minus 4 lots of minus 2 lots of 15, which is 1 plus 8 lots of 15, which is 121. So b squared minus 4ac is more than 0 in this case. And if b squared is more than 0, b squared minus 4ac is more than 0, like we said in the last one, there are two distinct real roots. So that's what we have. Okay, wait for it to load. It's been really slow marked up today. Here we go, another example. If f of x is equal to 3x squared plus 2x plus k, find the range of values for k for which f of x equals 0 has two distinct roots. This sounds a lot more complicated. You follow a very similar rule to last time though. So, in this case, a is equal to 3, b is equal to 2, and c is equal to k. We want it to have two distinct real roots, like it says up here. So, b squared minus 4ac must be more than 0. So we'll then sub in our a, b, and c to that. So we get 2 squared minus 4 lots of 3 lots of k must be more than 0. Which can then be rearranged to get 4 minus 12k is more than 0. Which means 4 is more than 12k. Which means a third is more than k. And then there's a secondary question for this one. Find the range of values for k for which f of x equals 0 has one repeated real root. So we found the discriminant before was 4 minus 12k. So we can start with that. 4 minus 12k, but this time equals 0 rather than more than 0 because we want one repeated real root. And that rearranges to get 1/3 equals k. And then for this one, again, discriminant 4 minus 12k, but we want no real roots, so we want it to be less than 0, so 1/3 is less than k. Cat. Okay, here's another example. The equation kx squared plus k plus 3x plus 4 equals 0 has two distinct real roots. Show that k squared minus 10k plus 9 is more than 0. Find the set of values of k which satisfy this inequality. So here we have a equals k, b equals k plus 3, and c equals 4. We want two distinct real roots, so we want the discriminant to be more than 0. So we'll sub in a, b, and c into that, and we get k plus 3 all squared minus 4 lots of k lots of 4 is more than 0, which can be rearranged to get k squared plus 6k plus 9 minus 16k is more than 0, which can then be rearranged to get k squared minus 10k plus 9 is more than 0. And that is what it wanted us to show, so we've done that bit, which I've put as required. But then it also wants us to find the set of values of k which satisfies the inequality, so we're then going to do k minus 1 lots of k minus 9, so we just factorised it, is more than 0. And you can solve this to get k is less than 0, k is more than 9. You can solve this on your calculator. If you go to the inequality mode and go to the right polynomial and stuff, you can solve it. You could also solve it by hand. In an exam quiz, I would have solved that on my calculator much quicker and much easier. Yeah, I believe that's the end. Yes. So thank you for watching this video. I hope you found it helpful. I will leave an iCard to the playlist, so if you want to watch some of the other videos on AQA A-Level Maths, you can. Don't forget to like and subscribe so that more people can find this channel and do well at AQA A-Level Maths. And I hope you'll be back for the next video. Bye bye!